Well, welcome back to the channel. Hope everybody's doing well, and in today's video we are looking at inrush current measurement on our current clamps we see in front of us here. Just to go through the clamps that are here, we've got the Kaiweets HT208D there. That's got a 100 millisecond inrush measurement window for a tolerance of 5% plus 10 digits, and that is an actual tolerance for the inrush function specified in the manual. In the UK, this will set you back 50 to 60 pounds. Flir CM46, this actually has an 80 millisecond window for inrush measurement and 2% plus 5 digits. However, that tolerance is taken from the AC current measurement, as there isn't a specific inrush tolerance for this instrument in the manual. In the UK, this will set you back £275. Moving on to our Flir CM55 here, we're back to a 100 millisecond window, but this time the tolerance is 3% plus 5 digits. Again, that is AC only, £230 for this one. You also notice that this one here is a Rogowski coil as opposed to a standard magnetic clamp. So this meter will only measure AC current. It doesn't have any capability to measure DC current at all. We're on to our RS Pro 158B here. Now this is actually a clone instrument from Apple Technologies. The measurement window on this is 100 milliseconds. We are on a 2.5% plus 5 digit tolerance, and this is actually an inrush tolerance specification in the manual as well, so similar to our Kaiweets. In the UK, this is £490. Over on the far right here, we have our Testo 770-3, again a 100 millisecond window, 2% plus 5 digit tolerance. That is an AC current measurement tolerance. That will set you back about £180. And our final clamp is our Uni-T UT216C. 2.5% plus 5 digits tolerance on this for AC current measurement. I don't have any specifications for the inrush measurement for this whatsoever in the manual, although it can actually do inrush current measurement. This will be £75 to £85. And the final instrument here is the HT Neptune. Obviously a multimeter. To use the multimeter for current measurement you need a current clamp adapter with it, which we've got there. However, this has some pretty good functionality for inrush current measurement. It does measure a 1 millisecond peak, and then it will measure the inrush current from between 16.7 milliseconds to 200 milliseconds over 7 different stages. So quite a bit of measurement functionality to do that, and it does specify a tolerance of 2% plus 2 digits, including the clamp adapter there as well. The other difference between this one is that this is the only instrument I have that has a specification for measuring AC and DC inrush, whereas all these other instruments, the specification that is there is for AC only. Okay, so I will knock this out of the way and set up the clamp tables to measure the current with, and I will do the vast majority of the testing on the HT208D here, because that's the instrument that appears to be of interest to most people, and then I'll just report on the others by exception. So we're set up with our HT208D here. We just can turn him on to the 60 amp range there, and if I just force this into a range mode to get to inrush, you have to use the function button, and you see as soon as I hit the function it switches out of range and goes to auto. So there's VFD, there's inrush. Range now no longer works, so we are stuck with what the instrument sees. I set this up with our solid wire, and we're kind of in the centre as best as we can. Now what I have found is that these do have a trigger level to them as well, which isn't stated in the manuals. So I'm on 50 Hz AC. I hit the go button, trying to inject 6 amps. It has injected it, and there's no reaction to the meter, as you can see. We'll take it
I've done these tests so I know where it's going to act. 10 amps it will start to act on. So here's 10 amps being injected at 50 Hertz. And you can see we've got 9.69 amps, which is very respectable. So once we've done one measurement, you have to kind of go back through things again to initiate another measurement. We're now on 20 amps. Give that a go. You can see we've got 19.54 with that one. So this is a 30 amp test that we're going to do, again at AC, 50 Hertz. 29.61. So the max this test set can deliver is 60 amps. So we'll just give that a go. And you can see we've ended up with 63.7. So pretty good set of results there for the Kaiweets. What I'm going to do now, so that's all the AC tests done. What I've done now is convert the test set to DC, and we'll go through the same test points. Setup on the instrument is exactly the same. That was 10 amps DC, and there was no response. So we'll go up to 20 amps. So that's our 20 amp response, and we've got 18.12, which is slightly below the 19.54 we got on AC measurement. We'll go to 30 amps. We'll reset. So that's our 30 amp measurement, which is, again is below the 29.61 we got at 50 Hertz. We'll take him up to our 60 amps. We need to reset. We'll go 60 amps. Okay, so for some strange reason it won't put out 60 amps on the test set. It's giving me an overload error. So we've dropped it to 50 amps. It's done the same again. So we have tried taking it up to our 60 amps, but the test set doesn't like it. So that's kind of the end of the tests for our HT208D with a single turn measurement. So I'll move on and I'll test the others. And as I said, all I'll do is show you ones that haven't worked correctly. So I thought I'd just show you the CM46 out of interest. It operates slightly differently to the Kaiweets. We are injecting 6 amps DC. We'll go for that. And there you can see we've got 5.5. Now I'm not going to reset anything. I'm going to go to 10 amps. I'm going to inject that. And you see the meter responds 9.3 amps. We'll go up to 20 amps, and this is all DC, remember, so fairly respectable readings. 20 amps, 18.8 on that, so this meter doesn't need to be reset if you're injecting a higher current. If I go back down to 10 amps, I didn't try this, and just see if it, I would imagine it doesn't reset then. No, so it's not picked that one up. So if you're picking up an increased current injection, you don't need to reset the instrument, but if it's a lower one than the previous reading, then you do need to reset the instrument. And with this one, it's just a straight hold down, and it goes to inrush measurement. So we'll just show you our CM55 here, our Rogowski coil unit. We're going to inject 20 amps at 50 Hertz. To get this to inrush, just a simple press of the inrush button there. And we hit the go button. And you can see we get 17.66, so fairly reasonable. It's a little bit lower than the initial reading I got. Let's just convert this all to DC. So reset again for inrush measurement. We're now going to inject 20 amps DC. We'll show you there. We've got 6.96, which is obviously way out. And I guess it's reasonable to expect that into it, with it being a Rogowski coil. It doesn't really like DC anyway, although it picks up a rate of change, so it works with AC, but we're just not seeing that same functionality when it's on DC, so it doesn't look like this unit is too good for DC inrush measurement, but fairly reasonable for AC inrush measurement. So we are set up with our RS158B instrument. To get this into Inrush, we go to mode, brings our different modes up, we go along to Inrush and hit OK. It does now say Inrush on the screen there. I'll just inject 20 amps AC just to show you. And we've got a reading of 20.20 this time. Last time we got 20.17 on the first test. So that is all fairly respectable. In fact, it's probably one of the most accurate readings I've had up till now. We will just convert this all to DC. So we're now going to inject DC amps. So this doesn't have the feature of the CM46 where if you re-inject it carries on going. You have to reset this one, which is just a couple of clicks of the OK button, and we're going to inject 20 amps DC now. And you can see we only got 12.95. First test is 12.82 amps, so very similar to the CM55 that it doesn't appear to like measurement on DC. I think the CM46 and the HT 208D are going the best for DC inrush measurement at this moment in time. So we'll get these out of the way and move on to the next batch of instruments. Okay, we're with our Testo 770-3 unit, and to get him into Inrush, we just hit the button there, single press. Okay, we'll centre him on the clamp. We are 20 amps, 50 hertz. Go button on him. And so you get 21.1, which is pretty accurate. This doesn't do like the CM46, you have to reset this one, but we'll just flick him to DC. So we'll just reset him now. Just a single press resets this one. And we hit the run test, and we're on 20 amps DC. And you can see we only get 9.1, so again the Testo seems to be performing very similar to the previous 2 or 3 instruments. Yeah, it's only the HT 208D and the CM46 that's got anywhere near accuracy for DC current measurement. Put him out of the way. So I'll just show you the Uni-T 216C because we've had better success with that. We'll just go to the Inrush measurement. It flashes up rush and then it goes back down to 0, but it is sitting in Inrush mode. We'll go inject 20 amps DC on that one. And you can see we get 16.7, so a little bit out, but much better than all the other instruments. So we've just reset the test set to 20 amps 50 hertz, so we're AC. We'll inject then. And you can see we get 19.3, so pretty accurate, just to show you as well. This works on AC and DC. I got 30 amps, haven't reset the instrument. But we get 29.1, so it knows if it gets an increased current, it will record that, go back down to 20 amps, and it will just sit there on 29.1 hopefully. Yeah, so it doesn't change if the inrush is less than the previous reading, but if it goes over the previous reading, it does automatically detect that, unlike a lot of the other instruments out there. So we'll get rid of him. So I'll just show you the operation of the HT Neptune here. To get him into current mode, we flip round to the current. It asks us for the setting that we're on the range. We're on 40 amps AC there, so we can go and hold that. To get this into Inrush, we press on the button, and then we find hit IRC, Inrush current. We do have to activate this one, so we have to hit the go button again, and we get the little timer up there to say that we're ready to go. We're going to inject 20 amps AC, 50 hertz, and you can see we get 20.30 amps on this occasion, which is all well and good. It's timed at 100 milliseconds there. You can use the arrow keys and you can flip to 150 milliseconds. You can see it's dropping off there, and 175, 200, dropping even lower. And then we go back round to on the 1 millisecond peak, so the test set put out 32 amps initially. And then at 16.6 you can see it's dropped down to the 21.9, 20.52, and so on. So pretty powerful instrument in that respect. We'll just convert him to DC on 20 amps. I'm going to leave on the AC function here. We hit the go button again to get our timer back up. We'll initiate the test set. And you can see that on this occasion we get 14.77 amps, so a little bit too low. However, what I'm going to do is just flick him round onto 40 amps DC on the clamp adapter there. Hit the go button again. And we're going to hit the test set initialized. And you can see we get 20.09 amps. So if you select DC function, this will measure DC inrush amps very, very nicely. Again, we can go through the actual settings, 150 milliseconds, 175. You can see it changing. Much better response on DC for the test set. You can see it only went up to 22.6 amps peak on current injection there, and then quickly dropped that down to the 20. So there you go, that's the HT Neptune. That's all the results completed on the single turn. So I'll correlate them up and we'll see how we got along. So here's our results table. We've got the top two tables there of the inrush current measurements. That shows the readings that I made for each of the instruments, and then the deviation from the nominal value that was being injected. The very bottom table there, that is the allowable tolerance bands calculated based on the specifications for each of the instruments there. So back at the top, our Kaiweets HT208D for AC measurements. We've lost one reading, the very first reading, and then we pick up on the 10, 20, 30 amps, which are all within spec. The 60 amp reading is slightly above spec. I think that could be due to the issue of just the general accuracy of the instrument. I seem to remember at around about the 60 amp mark it changes range, and I had issues with that when I initially tested the instrument some while back. With regard to DC, we've only got readings for the 20 and the 30 amp. The 60 amp is my test set problem. That's nothing to do with the instrument. 20 amps and 30 amps we are reading low, around about 10% low for each of those readings. That might explain why it didn't pick up on DC amps, but it did pick up on AC amps if it's just reading that a little bit low and didn't hit the threshold at the 10 amp mark there. So not too bad a set of results for the HT208D there. Flir CM46 a little bit better. All of our AC amps readings are within spec. DC amps, the first two are in spec, although they are right on the very bottom range of the tolerance band there. And then for the 20 amp and 30 amp we have dropped below the specification there. Flir CM55, our Rogowski coil meter, I have no idea what's gone wrong with that. I tested it and retested it and played with the ranges. It just does not want to know. All the readings are out of tolerance for both AC and DC, so I need to do a little bit more work with that one and try and see what the issue is. The RS185B from RS Pro, AC amps, all good. Quite a good spec of readings there for AC amps, well within its tolerance bands. DC amps, we're miles out. Just can't use that for DC amps at all. Then our Testo 770-3. The first two sets of readings, the 6 and the 10 amps, couldn't pick up on AC or DC. Again, with our AC amps, we are reading high against all of the specifications, and our DC amps, they are reading low, and by quite some considerable amount, 50 odd percent out. So again, you can't use that for DC amps. Not sure why the AC amps is being an issue. I haven't actually run calibrations on that. I haven't done a review on the Testo unit, so I probably need to sit down and do that and just do some general current measurements with it and just see how accurate it is. Moving on, our Uni-T 216C, fairly reasonable response there for the AC, slightly out, slightly lower reading for the 60 amp measurement there. And then our DC, again, we are quite considerably out. They're all out within the specification. But in terms of giving you a general idea of the measurement, it's not too bad, is it? It's kind of operating similar to the HT208D. And then we move on to our HT Neptune, which is our multimeter with the
clamp adapter, and it's spot on all of the measurements, some of the best tolerances that you see across any of the readings there really, which is to be expected. It's the most expensive setup in there, and it does spec specifically to be able to read AC amps and DC amps, so all well and good with that one. So this will be the end of this video. I'm going to split these current measurements up into a two-part series. In part 2 I'm going to put the current clamps onto the multi-turn clamp table that I've got and push them out to the upper end of their ranges and see what kind of performance you get then. As I said, that's it for this video. Thanks very much for watching. I hope you found it useful, and I'll see you again in the next one.